This video covers how to factor quadratics of the form ax squared plus bx plus c using something called the AC grouping method. We learned in a previous video how to factor by grouping when there are 4 terms, but these only have 3 terms. So you might ask, how can you factor by grouping if there's only 3 terms? Well, the trick is, if there's only 3 terms and you want there to be 4 terms, you need some way to break up one of the terms into 2. This method, called the AC method, will break up the middle term into 2 terms so that everything will factor nicely by grouping, just like in the first video from this piece of notes. So let's go through the method and then we'll do a whole bunch of examples. So it says, first, if you have the trinomial, notice trinomial means 3 terms, ax squared plus bx plus c, and you have this a here, a being something other than 1, then if a is not 1, we cannot use the nice shortcut method that was in the previous video. Instead, we'll have to use this method, and it starts by multiplying a times c. Now you find 2 numbers that multiply to ac and add up to b. This is pretty similar to the shortcut method, but instead of just getting the answer right away, we use these 2 numbers to break up the middle term into 2 pieces. After that, you can factor by grouping. This maybe seems very complicated, but it's basically, let's figure out how to break up the middle term and then we can factor by grouping. So let's do it. First up, AC is 2 times negative 15, which is negative 30. So we go looking for 2 numbers that add up to negative 1 and multiply to AC, which is negative 30. Well, I have 2 such numbers. Those 2 numbers are negative 6 and positive 5. Now in the nice shortcut method for just x squared plus bx plus c, we were able to just write the answer immediately. But here, because it's 2x squared minus x minus 15, this 2 is really obnoxious. We can't write the answer right away. The answer is not x minus 6, x plus 5. You can tell this is not right because x times x is not 2x squared, and 6 times 5 is not 15. So we can't write the answer right away. Instead, we use the negative 6 and the plus 5 to break up the middle term. Instead of minus x, I write minus 6x plus 5x. And I keep the rest of it the same. Let's get a little more space. So this was step 1, was to find the negative 30. Step 2 was to find negative 6 and plus 5. And step 3 is to break it up into 4 terms. Why is 4 terms so nice? 4 terms is so nice because we can factor by grouping. Look at the first group. These have a 2 and an x in common. Look at the second group. The second group has a 5 in common. When I take 2x out of the first 2 terms, I am left with x minus 3. When I take 5 out of the second 2 terms, I'm left with x minus 3. And we go, whoa, I got x minus 3 in both places. This was because I very carefully chose the numbers negative 6 and plus 5 using the AC method. Now the 2 groups both have x minus 3 in common, so I factor out x minus 3. When I take x minus 3 out of the first group, it's just 2x. And when I take x minus 3 out of the second group, I'm left with 5. This plus in between the 2 groups survives right here. So 2x squared minus x minus 15 equals x minus 3 times 2x plus 5. It's pretty good. This is step 4. Okay, let's do a few more. Here's number 27. First off, we look at the 3. The 3 is annoying. It means we can't use our nice shortcut method. Instead, we'll use the AC method. It's called the AC method because we start by multiplying A, which is 3, by C, which is 15. Then we use this number. We look for two numbers that add up to 14 and multiply to 45. Oh my gosh. Okay, well, let's find some numbers that multiply to 45. 3 times 15 is 45, but these add up to 18. 9 times 5 is 45. Ooh, and those add up to 14, so this worked. So the two numbers are 9 and 5. Now, remember not to skip to the end. We only got to skip to the end when the coefficient of x squared was 1. If this was not here, we could skip to the end. But because of this 3, I just have to use the 9 and the 5 to break up the middle term. 9x and 5x is 14x. So I've copied down the whole question, except I've broken up 14x into two pieces. I broke it up into two pieces so that I would have 4 terms, so I could do factoring by grouping. The first group has a 3 in common and also an x in common. When I take 3x out of 3x squared, there's still an x left behind. When I take 3x out of 9x, there's a 3 left behind. Finally, what do 5x and 15 have in common? Well, the greatest common factor of 5x and 15 is 5. Factor out a 5, and you're left with x plus 3. The two groups both have an x plus 3 in common. So I can finish factoring by grouping by writing x plus 3 and then seeing what's left when I factor out x plus 3. What's left is 3x plus 5. Let's keep going. In 28, this 4 means no luck. I cannot do a shortcut. So I'll use the AC method. 4 times negative 15 is negative 60. So I want two numbers that add up to 4 and multiply to negative 60. If they only add up to 4, do they have to be really small numbers? No, because they multiply to negative 60. So the two numbers are going to be a positive number and a negative number. That's the only way they would multiply to a negative. So let's just try some. Like, I guess 15 times 4 is 60. Can we do plus 15 and minus 4? Those multiply to the right thing, but they don't add up to 4. I need a positive number and a negative number. Maybe like 10 and negative 6? Yes, 10 and negative 6 add up to 4. And they multiply to negative 60. So the two numbers are 10 and negative 6. What are those two numbers for in the AC method? In the AC method, we leave most of the problem alone and just use those two numbers to break up the middle term. No one can really argue with you if you have 4x and you say, well, 4 is 10 minus 6. I mean, you can break up 4 into 10 minus 6 if you want to. And we do want to because it lets us factor by grouping. The greatest common factor of the first set of terms is, well, they both have a 2. Do they both have a 4? No. So 2. And they both have x. So the greatest common factor is 2x. When I factor out 2x, I'm left with 2x plus 5. How about the greatest common factor of the second two terms? The most common mistake I see here is not paying attention to the minus. If you don't pay attention to the minus, you might just get that they have a 3 in common, and then you would end up with this. Don't write this part down if you're copying it all. If you just take a 3 out of the second two terms, you'll end up with this. And you'll find that your two groups don't have anything in common, and so factoring by grouping fails. This is why earlier on I suggested that when you have a chance to take a negative sign out for the greatest common factor, you should. So I will use -3 as the greatest common factor here. Then I will end up with factors that match. So take -3 out of both terms, and you'll end up with 2x plus 5. And now the two factors here match. So I can factor them out of both groups. How about number 29? Again, gross 12, so I'll find AC. AC is what I want the two numbers to multiply to. I still want the numbers to add up to B. So they add up to 20. Two numbers that add up to 20 and multiply to 36. 9 and 4 are not big enough. They do multiply to 36. To make bigger numbers, I can kind of like steal factors of the little number and give them to the big number. So like 4 is 2 times 2. If I steal one of the 2's, then I'll make 9 larger. So let's try 18 and 2. Yes, 18 and 2 multiply to 36 and add up to 20. So I'll use these two terms, these two numbers, 18 and 2. Again, these two numbers are used not to write the answer right away, but to break up the middle term into two pieces so we can factor by grouping. I just broke 20x into 18x and 2x. Okay, what do the groups have in common? Again, factor by grouping is two little greatest common factor problems, and then a third big greatest common factor problem. Oh dear, 12 and 18 have a lot in common. Like, they're both even. Do they both have a 4? No. Ooh, they both have a 3. So they have a 2 and a 3 in common. That means they have a 6 in common. I think 6 is the biggest number that 12 and 18 have in common. So we'll go with 6. And then they both have an x. So the greatest common factor is 6x. When I take 6x out of 12x squared, I get 2x. When I take 6x out of 18x, I get 3. Then I look at the second two terms. The second two terms have nothing in common. What you've noticed a couple times is that if they have no factors in common, the greatest factor I can find that they have in common is just 1. You can always factor out a 1, because when you factor out a 1, it doesn't do anything. So if you're looking for a greatest common factor and you can't find one, just go with 1. It always is at least a common factor, and sometimes it's the greatest common factor. You know you did it right if the two factors here match. If the two factors don't match, you go back and see what you messed up. But here, 2x plus 3 matches, so I'll take out 2x plus 3 from both. And what's left when I factor out 2x plus 3 from each term is 6x plus 1. I think that's the end of the page. Yes. Looks like we've got some more here. Number 30. Number 30 says, what if it's 2x squared plus 11x plus 12? Well, AC is 24. I'm using AC because of this 2. AC is what I want the numbers to multiply to. I still want them to add up to B, which is 11. Sometimes you'll just guess correct on the first try what the two numbers are. Here, the first thing I thought of was 8 times 3 to make 24. If you tried 6 times 4 first, well, 6 and 4 don't add up to 11. But 8 and 3 add up to 11, so I'll use these. I use them to break up 11x into two pieces. Now I have 4 terms. I can try factoring by grouping, which is, let's look at the 2 groups, see what's the greatest common factor of each group. The first group, both terms have a 2, and both terms have an x. Take 2x out of 2x squared to get x, and take 2x out of 8x, you get 4. For the second group, what do they have in common? Well, they have a 3. When I factor out 3, I get x plus 4, and I'm happy because I got x plus 4 twice. So now I can factor as x plus 4 times 2x plus 3. Let's see. 8x squared minus 14x plus 5. The numbers are getting a little large and obnoxious. A good defense for yourself to save yourself from difficult problems is you should always be trying to look for an easy method just for a minute before you try the hard method. So when the numbers get a little bigger, you should say, is there like a greatest common factor I can take out of all 3 of these from the beginning before I do the AC method? Here, 8 and 14 and 5 don't have anything in common, so it didn't help me here. But whenever you look at a problem and you're like, ooh, this looks like a hard one, try to make it easy first. Like, try an easy method before a hard method. Anyway, AC is 40, so I'm looking for 2 numbers that add up to negative 14 and multiply to 40. Since they add up to a negative, but they multiply to a positive, the only way for that to happen is if they're both negative. So I'm looking for 2 negative numbers. Negative 2 times negative 20 would make 40. Oh, that's way too negative. So maybe I'll steal part of negative 20 and give it to negative 2. How about negative 4 and negative 10? Yes, negative 4 and negative 10 works. What are these for? They're not the answer. Like, it's not x minus 4, x minus 10. This isn't even close. X times x is not 8x squared. And 4 times 10 is not 5. The shortcut only works if like this coefficient, if a is 1. Instead, we are using negative 4 and negative 10 to break up the middle term. Then we can factor by grouping. These first 2 terms, well, they've both got a 4, and they've both got an x. When I take 4x out of 8x, I'm left with 2x. What if I take 4x out of 4x? Is that nothing? No. Taking 4x out of 4x leaves you with 1. And this minus will still be here. Make sure that if you ever factor something out of itself, that you end up with 1. Then, ooh, this problem has all the tricks. Remember that if we have a minus here at the beginning of our 2 terms, we should try to factor out the negative sign. So I'm going to factor out a minus 5 from both of these terms. When I take minus 5 out of minus 10x, I get 2x. What happens when I take minus 5 out of 5? When I take minus 5 out of 5, I get negative 1. Good thing I took out negative 5 instead of just taking out 5, because otherwise I would not have gotten a match here. And the match is what allows me to finish the factor by grouping. Nice. 2 more. Oh no, what is this? Again, because the numbers are so huge, I need to try easy methods before hard ones. So hopefully these have something in common that I can factor out to make the numbers smaller from the beginning. Oh no, but 49 is made entirely of 7s, and 10 does not have any 7s in it. So, this problem is just hard. Oh well, let's do it. AC is 10 times 60. Well, that's 600. So we're looking for two numbers that add up to 49 and multiply to 600. Is this even a thing? Okay, 600. 600 is 20 times 30. 20 times 30 is too large. Those add up to 50. Wow, that's really close to 49. I need the numbers, like the closer together the two numbers are, the higher their total will be. Wait, is that true? No, the closer together the two numbers are, the lower their total will be. Like if you pick numbers that are really far apart, like 600 times 1, then you make the sum really big. Like both of these pairs multiply to 600, but this one has a really, really big total, way too big. This one is like just a little bit too big. So I need to make the numbers a little closer together than 20 and 30. It won't be 21. It won't be 22. Because 600 is made entirely of 2s, 3s, and 5s. So it could be like 24? Doing it on a calculator. 600 divided by 24 is 25? This does actually work. So when the numbers are really big, just don't give up. Use this idea that the further apart the numbers are, the bigger their total is. So when I found 20 times 30 and the total was a little bit too big, I tried to find two numbers that were closer together, and that led me to 24. So the two numbers are 24 and 25. Let's use them. We use them to break up the middle term. The reason we wanted to break up the middle term was so we could factor by grouping. What do the first two terms have in common? The first two terms have a greatest common factor of, well, 10 is 2 times 5, and 24 has a 2 but no 5s. So the greatest common factor will have a 2. And then x squared and x have an x in common. So the biggest thing I will be able to factor out is 2x. When I take 2x out of 10x squared, I get 5x. When I take 2x out of 24x, I get 12. Okay, what do 25x and 60 have in common? Well, 60 is like 6 times 10. So it's like 60 has a 5 in it, because 10 has a 5. I guess 25 has a 5. Let's see if just 5 is good enough. When I take out a 5 from 25x, I get 5x. And when I take a 5 out of 60, what I mean is 60 divided by 5, and that's 12. Well, the two factors matched, so we did it. So I can factor out 5x plus 12, and what's left is 2x plus 5. Nice. Okay, let's do one more. Try to make a little space here. Again, anytime the numbers are really big, I really recommend you try to get out of the really hard problem. Like 36 times 30 is not good. Like this 600 was kind of at the limit of anything reasonable. So do these have something in common? They do. These have a greatest common factor of 6. So we can make the problem a lot easier by using the easy method before we employ the hard method. This is a theme throughout all of this class. Try the easy method first. It might make your life a little bit easier before you do the hard method. Then we'll do the hard method, namely the AC method, on just this part. The final answer will have a 6 and also the results of whatever we get from the AC method. So AC is 6 times negative 5. We want two numbers that add up to negative 7 and multiply to negative 30. This is so much better than if we looked for two numbers that add up to negative 42 and multiply to negative like 1,000. What are these numbers? They multiply to a negative, so one of the numbers will be positive and one will be negative. 6 and 5 is no good. There's no way to make that add up to negative 7. Plus 3 and minus 10 will work. They add up to negative 7 and they multiply to negative 30. Now notice This 6, I'm writing it at every step. Why am I writing it at every step? It's so I don't forget it. All I'm doing in this step is breaking up the middle term. And the habit to get into is to just copy everything down at each step, and then you don't have to remember anything ever. You could get up from this right now and walk away and come back, and all the information from the problem is still right here. Okay, then we factor by grouping. This 6 is just along for the ride. The first group has a 3 and an x in common. When I take out 3x, I get 2x plus, I took 3x out of 3x. Do you remember what happens when you take something out of itself? When you take 3x out of 3x, you're left with 1. Then in the last two, this problem's so good. The last two, they both have a 5 in common, but I'm not going to factor out just 5. I'm going to factor out -5. When I take -5 out of -10x, I get 2x. And when I take -5 out of -5, it's 1. So this thing after the 6, I can write it as 2 factors. I'll take out 2x plus 1, and what's left is 3x minus 5. Ooh, what a good problem. That's a really good problem. So what's the takeaway from this? The takeaway is sometimes it's like in number 32, where it's the AC method, the numbers are big, and it's painful, and there's nothing we could have done about it. But if you spend just 10 seconds at the beginning of the problem trying to make it easier before you do it, you sometimes get a huge payoff, and it doesn't cost that much to try. Here we took the 6 out at the beginning, and we got a huge reward. It made number 33 way easier. In the next video, we'll just do a nice special case that's another shortcut. That problem we just did is definitely the hardest problem from this note packet. So if you made it through, good job. You should feel proud. See you in the next one.